Moving on with the B part of the experiment 6th. Here we have to check the pulse width modulation of the amplitude of the given input. So we have been given the interfacing diagram here. So we'll be giving the input through ADC IN1, that is PA1 pin to the STM board, and then we'll be collecting the output through PD9 and connecting the PD9 pin to the CRO. This is the pin configuration of the CRO given. So we'll be using either the scope channel 1 or the scope channel 2, or we can use the negative scope channel 1 or scope channel 2. We have to also use the grounding wire for both of the cases. Grounding is important for the device to not damage our device. This is the JTAG pin of the CRO. So this is how it looks. This is the notch. Ensuring that the notch is up and the pins are as shown, you have to insert the JTAG properly so that you won't damage the device. Moving on with our STM-Cube-MX, again we should click on Access to Board selector, wait for a while, type in your board name, double click on the board, click on yes, let it load for a while. Do the same as the previous experiment, that was 6A. Clear all the pinouts, yes. After clearing all the pinouts, go to System Core, go to RCC, set the HSC clock to crystal and ceramic resonator, go to System, go to Debug, click on Serial Wire. After doing this, go to Analog, go to ADC1 and click or check the IN1 so that our PA1 will be our ADC IN1 input. The only change we have to do is that we have to set our PD9 pin over here as our output to our CRO. So I'll set it, right click on PD9 and set it as GPIO output. See the configuration over here. Here the clock is PLK2 divided by 4, which shouldn't be. So we'll go to the clock configuration, we'll choose our HSI as our PLL source mux and set our APB2 peripheral clock as 60 MHz. So we have set our APB2 peripheral clock as 60 MHz. Now going to pin configuration, we can see that our clock prescaler is PLK2 divided by 2. Our resolution should be 12 bits. Down here, our sampling time should be 3 cycles. Now we can give name to our project. Set up the target as shown in the previous video, and in your user core, go to main C, type in the code as given in your manual and then click on build to check for your errors. As shown in this figure, take your board and the orange wire or the channel wire should be connected to PD9 and the ground wire should be connected to GND here. And make sure that your ADC IN1 input is connected to your PA1 which will be on that side of the board. Your input will be your voltage, DC voltage, which will be given by an external voltage supplier. You can vary the voltage from 0 to 3.3 volts max as given in the statement of the problem. Make sure that you have Waveform 3 software installed in your system. You have to go to Windows, go to program file x86, go to Diligent, and then go to Waveforms and then click on the last option, Waveform. After clicking on that, after opening the Waveform software of AGILENT, you have to click on Scope. Make sure your channel 2 is untick and channel 1 is tick, because we are using the channel 1 of the CRO, and these are your settings which you can set or assume for your bandwidth modulation. You can change these settings as per your adjustments. After doing this, you have to press on the run button, and then you can see the bandwidth modulation on changing the voltage of external supplier. Thank you.